So moving further into chapter 14, this is like section 4, working with what we call rational equations. Question 4 now says solve the equation and check for extraneous roots. So extraneous roots kind of means excluded values. So kind of what we just did. So again, one of the first things is we need to look for values to exclude. So one of the things we pick up on is division by zero is undefined. So if there's a value of x that generates a zero in the denominator, we must be excluding this value. So notice how x appears in the denominator. So if you look at that 5 over x, what can you pick for x that's going to make this turn into a zero? Well, if you turn x into a zero, then that will be 5 over 0, and we cannot divide by 0. That's going to create an error or undefined. So one of the excluded values is going to be 0 then. So 0 is kind of excluded. So as we move on and if we solve this equation, if x ends up being 0, we cannot use it in the original equation, so we have to exclude it. So what's going to happen is we're going to actually manipulate this equation a little bit. So if we multiply an equation by what's called the least common denominator, that can be used to eliminate fractions in an equation. So notice how there's a 3 and x in the denominator. So the least common denominator is going to be the 3 and the x. Those would be the two common factors that we need there. So we need a 3 and an x to get rid of both fractions at the same time. So we're going to multiply this equation by a 3 and an x. So what I'm going to do is I'm going to go ahead and rewrite this problem. So I'm going to put a 3x here, and then on the left side, I'm going to use parentheses for multiplication, 2/3 plus then this 5 over x. And then on this right-hand side, I'm just going to multiply 1 times 3x over here. Now remember, the reason we multiplied by this 3x is to divide out the fractions. So when I do this first part, notice that these 3's are going to cancel. So this 3 and this 3 are going to cancel. So I'm not going to actually mark it out at this point. I'm just going to kind of think I've canceled it. So really what this tells me is only the x comes through to the first term. So when I multiply 3x times 2/3, the 3's cancel. So the only thing that's going to come through into the parentheses would be the x on that first term. So that's going to give me x times 2, which turns into a 2x. Now, when I multiply the 3x to the second term, notice how the x's cancel. So really the only thing that's going to go through here is the 3 times the 5. So the 3 times 5 is going to give me a 15. And then on the right-hand side, 1 times 3x is going to give me then this 3x. So by multiplying by 3x, I created an equation that no longer has fractions in it. So when I multiply the 3x to the parentheses, the 3's cancel, so the x comes through, x times 2 is 2x. And then when I multiply the 3x to the second piece, the x's cancel, which leaves me a 3 times 5 coming through, which is 15. Now, to solve for x, we need to get the x on the same side of the equation. I usually pick on what's called the little guy. So I want to get the x on the same side. 2x is smaller, so what I'm going to do is subtract the 2x here, but I have to also subtract the 2x over here. So again, this can be done many ways. So notice how these 2x's are actually zero out. Now I'm going to get a 15, and x take away 2x is actually going to just be x. So that's done. So my solution is going to be 15. So that's our solution set, or we could simply say x equals 15 is our solution. Now, notice how since we didn't get 0, we don't have to worry about this. So we don't have to throw out the 15 because the only number we throw out is 0. So 15 remains our solution.